Well, this is a classic one. Cannon fired from a cliff, possibly even going to be a sailing boat out there somewhere in the water. Will the cannonball hit the sailing boat? How far is it going to travel? What's the range of this one? Now, this is a little bit more complex because we can't just work out the time to the top of flight and assume that we can double that. Because if you look at think about our flight is a long way from symmetrical. The top of the flight happens here in a shorter period of time. It's going to take a longer period of time because it's got further to fall. So we have to work out the total flight time in two separate steps, the time to the top of flight, and then we have to recalculate how long it's going to take to fall from there. So again, we're just purely and utterly thinking about the vertical component of the motion. At the moment, we're going to ignore the horizontal velocity and we're just going to consider the vertical velocity. So the first thing that we need to do is we need to work out, if we're given what u is, we want to work out what u, x, and uy are and store them away for a little bit later. And so uy equals u sine theta and x equals u cos theta. So uy, let's see, what's our u? Is out 60 and it's 30 degrees. Okay, so 60 times the sine of 30 gives us 30 meters per second. So our uy is 30 meters per second and our ux is 60 times the cos of 30 degrees, which is going to come out around about, let's call that 52 meters per second. Okay, so now we've got our initial velocities. Our uy equals 30 meters per second, sorry, that didn't look right, equals 30 meters per second, and our ux is 52 meters per second. Okay, so now we've done that, we've calculated what our ux and our uy is. Let's think about purely and simply the uy component. So again, time to the top of flight, we've done this many, many times now. gt, therefore t is going to be equal to v minus u on g, which is going to be equal to 0, because we're considering the top of flight, the vertical component is 0, minus uy is 30, divided by minus 9.8. So the time, so this is the time to the top of flight, is going to be whatever that comes out at, which is 0 minus 30 divided by minus 9. Oops, let's try that again. 0 minus 30 divided by 9.8. That's looking a whole lot better. Okay, so it's the time to the top of flight is going to be 3.0, let's not round it off too much because we've got a fair bit more working to do, 3.06 seconds. Okay, so the time to the top equals 3.06 seconds. Now we can't just double that, we can't assume that it's going to take the same amount of time. In the next 3.06 seconds, it's actually going to be at this point here, which is not down at the ground. It's got another 100 meters to fall once it gets to that point there. And we don't know what the initial velocity is at that point, so it's not a good idea to go to there and try and do it in 3 time intervals. We're just going to work out the T1, which is the time to the top of flight, and T2 for that whole second fall. So we need to know what height it's going to fall from. It's going to be more than 100 meters because it's made some kind of gains vertically. It's up in the air somewhere vertically. And so the quickest and the best way to find out how high in the air it is at this point here, that's the moment in time we're considering. That is now our initial velocity, and our starting point and our ending point is going to be when it hits the ground, hits the water. So we need to find out how high that is. It'll be 100 meters plus whatever height that it's gained. So v squared minus u squared equals 2gr. This is what we're looking for, that change in displacement above the ground. So r equals v squared minus u squared divided by 2g, which is going to be 0 squared. So we're considering getting up to the top of the flight. Our initial final velocity is 0. Our initial velocity in the uy component is 30 squared divided by 2 times minus 9.8. Let's see what that comes out at. Okay, so we've got 0 minus 30 squared divided by 2 times minus 9.8. And that's going to give us 45.92 meters, we'll call that. 45.92 meters. Okay, so this is, sorry, that's y, I should say. So this is how much height that it's gained. In other words, this is the extra height that it's made here. It's going to be 45.9. Okay, so now the total distance that it has to fall, the height that it has to fall from, is 145.9 meters. Okay, so let's just consider that as we're trying to work out the second time interval. Now we're considering that our initial velocity in the y component is 0. We're taking this top of flight as the beginning of our time, and we don't know what the final vertical velocity is. In fact, we don't really care. All we want to know is how long it's going to take to get there. Now, that one there would mean that we need to know the initial and the final velocity, but that's not going to be much help to us because we don't really want to bother working out what the final vertical component of the velocity is. So we're going to have a look at using this equation here. Okay, so again, we're just purely considering the y component is uyt plus a half gt squared, but remember uy equals 0, which means that term is 0, that term then just disappears. So ry is a half gt squared, or t squared equals, well, let's just do one step before that. Let's go 2ry equals gt squared, so therefore t squared equals 2ry on g, or t is going to be equal to the square root of 2ry on g. Okay, let's put that one away for the moment and think about this. So now we've got the time. This is the t2, the time to fall that second height there. That's going to be equal to 2ry, so t2 is going to be equal to the square root of 2ry on g. Now we know everything on the right hand side. We can simply substitute that in to work it out. ry is the change of displacement, which is 145.9 meters. It's 100 plus the 45.9 divided by minus 9.8. Now, it's going to be going downwards. The change in displacement is going to be downwards. So actually, that's a negative 145.9 meters because we want to go downwards. We're going to fall. So let's grab our calculator and work that one out. Okay, we want the square root of, whoops, go back one, delete, yep. 2 times 145.9, but that was a negative number, divided by, and let's have a look at what's here, 9.8, it's a negative 9.8, bang. So T2 is 5.46, T2 is 5.46 seconds. So now, time at the top was 3.06. See how the second time is actually longer than that? It's 5.46 seconds. Whew, that's a lot of working out to be done in this one. Okay, so we're nearly there. Now we've got our total flight time. So the time total is going to be equal to T1 plus T2, which is going to be equal to 3.06 plus 5.46. 3.06 plus 5.46. So it's going to be 8.52. Oops. 8.52 seconds. All right, we're on the home straight from here. We then simply need to substitute that in. Rx, the range, the distance it's going to go on the horizontal component is going to be simply Ux or Vx, doesn't matter which one you use, times the time. So that is going to be, what's our Ux? Again, it was Ux is 52 times 8.52. 8.52 times 52 is going to give us 440 meters. Okay, so it's going to go around about 440 meters is our X range. And there we finally got it. I'll show you in another video a slightly simpler but more complex mathematical way of getting that out in fewer steps.